When you get taught proportionality, let's say d is directly proportional to t, you're told that you can immediately jump to d equals this k thing, which is called the constant of proportionality, and then you're always asked to find this k, and you don't really understand where it comes from or why it exists. We just get taught to find the k. So let's try and understand why this k exists. So imagine you've got a scenario where you've got two cars. This car's a slow car traveling at 3 meters per second, and then you've got a fast car traveling at 5 meters per second. So 1 second, 3 meters, 6 meters, 9 meters, and so on. 5 meters, 10 meters, and 15. So let's try and establish the relationship between distance and time for car A. So what's the relationship between distance and time? Well, if I double the time, if I give the car twice as long to travel, then I expect the distance to be twice as long. So you times this side by 2. If I give the slow car 3 times the amount of time, then the car would have traveled 3 times the amount of distance. It's that kind of a relationship. So we've established that if you times this by 2, you times this by 2. If you times this by 3, you times this by 3. So we know that d is directly proportional to t for the first car, for this car. Now let's do the same thing with the second car. Now the distance and time for the second car, if you double the distance, then you also, if you double the time, then you also double the distance. If you triple the time, then you also triple the distance. So the point here is that both cars will have the same relationship. D is proportional to t for the first car. D is also directly proportional to t for the second car. So they both satisfy this condition. But the thing is, the k will be different depending on the car. So for example, let's try and plot a graph for car A, for the slow car. 1 second, it would have traveled 3 meters. 2 seconds, 3 seconds, it would be 9 meters. Now so the graph will look like this, which is for the slow car here. And then if you look at for the fast car, 1 second it would have done 5 meters, 2 seconds, 10 meters, 3 seconds, 15. So it will look like this. Now this is a straight line, so it's going to be y equals mx plus c. It always goes through the origin, because at the start the distance will be 0. So you put 0 into the c, so really we don't need the c here. So this m here is your gradient. The gradient here will be the height divided by the cross for the slow car, in which case for the slow car it would be 3x. And then for the fast car it would be y equals 5x. Now x, the x-axis represents time, so it would be 5t. The y-axis represents d, which is this thing here, dt. Now this k, constant of proportionality, depends on your car. Here is 5. Up here, for the slow car, it would be 3. So this constant of proportionality depends on your scenario. If you're in a slow car, your k will be different from for the fast car. So that's where the k comes from. The k comes from really the scenario that you're in, for the slow car or the fast car. There are other instances which I will show you in the future. Okay.